14 billion years ago, something impossible happened. Every atom in your body, every star in the sky, every galaxy we can see, all exploded from a point smaller than the period at the end of this sentence. But here's what will blow your mind. The Big Bang might not be the beginning at all. We're about to explore colliding dimensions that birth universes, black holes that contain entire realities, and quantum loops that make time itself bounce backwards. If you're ready to discover what really came before everything, hit that like button and subscribe, because this journey will change how you see existence itself. Prepare yourselves. We begin. Picture this. You're trying to divide by 0 on a calculator and it just says error. That's exactly what happens when physicists try to understand the very first moment of the Big Bang. We call it the singularity problem, and it's been driving scientists crazy for decades. According to our best theories, if you rewind the universe like a movie playing backwards, everything gets smaller and smaller, until it reaches a point of infinite density and infinite temperature. But here's the thing that keeps physicists awake at night. Infinite anything in physics usually means your math has broken down completely. Think of it like trying to cram every person on Earth into a space the size of a pinhead. It doesn't work. The laws of physics we know and love simply stop making sense when you reach these extreme conditions. Einstein's general relativity, which beautifully describes gravity and space and time, starts throwing up its hands and saying, "I quit." Welcome to the smallest possible scale of reality, where everything you think you know about space and time falls apart. At distances smaller than 10 circumflex 35 meters, space isn't smooth like we imagine. It's bubbling and churning like a pot of boiling water. Scientists call this the quantum foam, and it's where the rules of everyday reality go completely haywire. At the quantum foam level, pairs of particles spontaneously pop into existence and then annihilate each other in less than 10 circumflex 43 seconds. Something extraordinary happened in the first tiny fraction of a second after the Big Bang. The universe expanded faster than the speed of light itself. Picture a balloon being inflated, but instead of growing steadily, it suddenly explodes from the size of a marble to the size of a basketball in less time than it takes light to cross a single atom. In just 10 circumflex 36 seconds, a region smaller than a proton expanded to the size of a grapefruit. This isn't just fast expansion, this is space itself stretching so rapidly that 2 points that were close enough to touch became separated by millions of miles instantly. Recent theories suggest that our inflationary period might have been just one episode in a much longer cosmic drama. Think of it like a mountain climber who has to traverse multiple peaks before reaching the summit. Each peak represents a different phase of cosmic evolution. Scientists are building increasingly sensitive detectors to search for these primordial gravitational waves. If they find them, it would be like discovering a message in a bottle from before the beginning of time. What if the Big Bang wasn't a beginning but a bounce? Scientists are discovering that our universe might be caught in an eternal cycle of expansion and contraction, where each Big Bang is actually the rebound from a previous cosmic collapse. Imagine a cosmic heartbeat that's been pulsing for eternity. This cyclic model solves one of the biggest problems with the traditional Big Bang theory. Instead of everything beginning from an impossible singularity, each cycle smooths out the wrinkles from the previous one. Think of it like a cosmic washing machine that cleans and resets the universe every few trillion years. Picture two vast sheets of space-time hurtling toward each other through a higher dimension that we can't see. When they collide, the impact creates our entire universe in a cosmic crash that makes the Big Bang look gentle. Think of it like two enormous soap bubbles floating toward each other in a bathtub. This is the ekphorotic scenario, named after the ancient Greek word for conflagration. Instead of our universe beginning from a single point, it emerged from the collision between two three-dimensional spaces called branes, moving through a higher dimensional realm that exists beyond our everyday experience. What if space itself has a smallest possible size like the pixels on a computer screen? Loop quantum gravity proposes that space is not infinitely divisible. Just like matter is made of atoms, space itself is constructed from fundamental building blocks called loops. Think of space like a piece of fabric. When the universe contracts during a big crunch, it can only squeeze down until the loops of space are pressed together as tightly as possible. At that point, space itself pushes back. It's like trying to compress a spring. The more you squeeze it, the harder it pushes back. Imagine a cosmic factory that never stops producing Big Bangs. Welcome to eternal inflation, where our universe is just one bubble in an infinite ocean of constantly expanding space. Think of it like a pot of boiling water where bubbles constantly form and rise to the surface. Our observable universe represents just one tiny region inside one of these cosmic bubbles. Beyond the edge of what we can observe, our bubble universe continues expanding. And beyond that, there are other bubble universes, each one created by its own Big Bang event in the eternally inflating space. What if our entire universe exists inside a black hole? When a massive star collapses to form a black hole, the mathematics suggests something remarkable happens. Instead of creating a simple point of infinite density, the collapse might create an entirely new region of spacetime that expands rapidly. If our universe is inside a black hole, then that black hole exists in a larger parent universe, and that parent universe might itself be inside an even larger black hole. It's black holes all the way up, an infinite hierarchy of nested realities where each universe is contained within a black hole in the universe above it. Recent computer simulations show that black hole interiors can indeed develop the kind of large-scale structure we see in our universe. Galaxies, galaxy clusters, and vast cosmic voids all emerge naturally from the gravitational dynamics inside a rotating black hole. What's even more fascinating is that every black hole in our universe might contain its own interior cosmos, each one a complete reality with its own potential for complexity, structure, and perhaps even life.